The following is the video solution from JSDT Solutions. Question 8 says, in the diagram, the graph of f of x is equal to negative x cubed plus 5x squared plus 8x minus 12 is drawn. A, B, and C are the x-intercepts of f. E is the turning point of f. T is a point on f, and G is a point on the x-axis such that TG is perpendicular to the x-axis. Okay, that's a fancy way of saying that T is vertically above G, meaning they share a specific coordinate. And lastly, they tell us that D is the y-intercept of f. Okay, so the y-axis has also been left out here. We'll just have to draw it, ensuring that it passes D. Okay, so that is D over there. And the first question is to calculate the coordinates of C if B is 1 and 0. So C is one of the x-intercepts. And to find that, we would naturally have to make y equal to 0, because at the x-intercept, y is equal to 0. So we have the equation of f, and we can make y equals to 0, but then we would have to factorize. So that's probably why they gave us b, to tell us that, hey, we've given you a factor, so you don't have to search for it. Okay, so this is our graph of f. Let's just rewrite it. Okay, so we're just going to make y equal to 0. Now that we have this, using the long division method, we're going to take the coefficient of each of these terms. So here, the coefficient of x cubed is negative 1, and then we have positive 5, positive 8, and negative 12. And around these, we're going to draw an L backwards. Now, the number that goes here is that value that when substituted into your equation, it gives you 0. And we already know what this value is. We don't have to search for it. Naturally, you would have to take the factors of negative 12 and you would have to substitute and substitute just to find where it gives you 0. But we don't have to do that anymore because they have given us b. They told us that b is 1 and 0. The y value is 0, meaning when you substitute x, it gives you 0. So the number that goes here is 1, and we know that. Okay, and now let's find the factors. So we drag negative 1 down, and then we say negative 1 times 1, and then that gives us negative 1. So negative 1 plus 5, because this is positive, and that gives us positive 4. 4 times 1 is 4, and then 4 plus 8 is 12. And then 12 times 1 is 12, and 12 minus 1 is 0, and we end at 0, so we know that this is correct. Okay, so this is what we have. You see these numbers here, these coefficients, they are the coefficients of our quadratic expression that this factorizes to. So this is x squared, this is for the x, and this is for the constant. So here is how we will write our factors when factorizing this. So that would mean that since x equals 1, since 1 is one of the numbers that works, it just means that x is equal to 1 is one of the solutions we will have. So the factor that it will be would be x minus 1. See, if you say x minus 1 equals 0 and you transpose the negative 1, you get x equals 1. And then the other factors come from here. So we're going to say negative and the variables with x squared and then plus 4x and plus 12 is equal to 0. Okay, so we're just factorizing this. And now all we have to do is factorize this part. So here we will say x is equal to 1, which we already have, or negative x squared plus 4x plus 12 equals 0. And let's factorize this. So it has a common factor of negative 1, so we can just multiply both hand sides by negative 1. And so this is x squared minus 4x minus 12 equals 0. Open up two brackets, equated to 0, and we're saying what times what gives us x squared? It's x times x, and what times what gives us negative 12, but can give us a negative 4 in the middle. We can try 6 and 2. So if we make the 6 negative, then 6 plus 2 is negative 4, okay? And they still multiply to negative 12. So this means that the other solutions we have are x equals positive 6 or x equals negative 2. And now we will just have to decide on which one is C that they asked us for. Okay, so C is way over here. So it's the positive and it's the biggest positive one that we have. So that is 6. So C is 6 and we now know that. And so that would mean that A is -2. Okay, so that's -2. We'll just keep that in mind. So let's just finally conclude that this means that C, the coordinates of C are 6 and 0. And that is our answer. Question 8.2 says determine the coordinates of E. So as we can see, E is one of the turning points. Okay, so the one with the positive x value. So to find the turning point, remember that this is the point where the gradient of this function is equal to 0. So that's what we're going to use. So let's go ahead and find the gradient of our function. We'll rewrite our function first. And we'll find the gradient of this function. To find the gradient of a function, you derive it. Okay, so we're saying f prime of x, but we're specifically looking for what the gradient is equal to 0. So we'll make it equal to 0. So deriving this function, coefficient times exponents, that's -3x squared, exponent minus 1, that's why it's a squared, and then coefficient times exponent is positive 10x, and that becomes a plus 8, and the x falls away, is equal to 0. Okay, so now that we have this, we can factorize it, but this is negative, so let's just multiply both hand sides by -1 to make it positive. So we have positive 3x squared minus 10x minus 8 equals 0. Okay, so what times what gives us 3x squared? That's 3x times x. And what times what can give us 8? Well, you could try 4 and 2 or 8 and 1. And let's just see which ones will help to form -10 in the middle. So let's say we tried 4 and 2. Okay, I can already see it would rather work like this. We could use 12 and 2. So it will form 12 if you put the 4 here and you put the 2 here. So that is 12x when you cross multiply 3x times 4 and x times 2 is 2x. And you see that if this stays -12 and this stays positive 2, then -12x plus 2x is -10x. So here, how do we get the 12x? We got it by saying 3x times 4. So we're going to give the negative to the 4 and the positive to the 2. So there we go. Our factors are 3x plus 2 and x minus 4 is equal to 0. And so therefore, to solve for x, we'll say 3x plus 2 equals 0. So 3x is equal to -2 when you transpose. And if you divide both hand sides by 3, x is simply equal to -2 over 3. Or here x is equal to 4. And those are our answers. Now we need to find which one specifically belongs to E. So remember that E was on the positive part, right? So this is what we're going to take for E. So let's find the y value belonging to this x value. We can find that by taking this x value and substituting it into the original function. So this is our original and we'll substitute it. So we're saying x is equal to 4 here. So we'll say f of, and in place of x, we say 4 equals -4 or cubed plus 5 times 4 or squared plus 8 times 4 minus 12. And let's find out what f of 4 is. And so that is 36. Okay, so we know that this is 36 now. Therefore, it means that the coordinates of E are 4 and 36. And that is our answer. You can also fill it in your diagram. Moving on to the next question. Question 8.3 says, for which values of x will f be concave up? Okay, so you see that you have two types of curvature or concavity on our graphs. So concave up and concave down. They want to find out the values of x for which it will be concave up. Now the point where the graph changes from being concave up to concave down is here at the point of inflection. So we could find that, or we could just deal with this the algebraic method, which is like this. To find out where the graph will be concave up, you can simply say this is where the second derivative is greater than 0. Okay, so let's go ahead and do that. We already have f prime of x, so we can start from there. Take f prime of x and then derive it further to get the second derivative. So if that is f prime of x, then the second derivative would be coefficient times exponent, that is negative 6x, and then plus 10, and of course that x will fall away. So this should just be greater than 0. This is a linear inequality, so just solve for x. So you can leave negative 6x here and say greater than and transpose, so that's negative 10. Then we'd have to divide both hand sides by negative 6. So what happens when you multiply or divide by a negative with inequalities? The sign will change direction, so it now looks like that. So therefore, x is less than negative 10 over negative 6. They both have a common factor of 2. So divided by 2 is 5 and divided by 2 is 3. So x is simply less than 5 over 3. And that is our answer. Question 8.4 says calculate the length of OG if the tangent to the curve at T is parallel to the tangent to the curve at D. Okay, so let's look at this, and I'm just pinning this to the screen and let's see what they mean by this. So the main goal is to find the length of OG. So we need to find the length of this line. And you see that in order to find the length of that line, you just need to know what that x value of g is. And to find the x value of g, you need to know the x value of t, since they are vertically in line, meaning they share the same x value. Okay, so they told us that the only information they gave us about this is that we have a tangent to the curve at t, but that tangent is parallel to the tangent to the curve at d. And we would have to find the length of OG. So what is that x value? Okay, that is a very interesting way, a very nice way actually, for them to give us information to find this x value at t, telling us that these tangents to t and d have the same gradient will help us to find out exactly what that gradient is. So if we're able to find out what the gradient at d is, we know the gradient at t. And if we can find the gradient at t, then we can find out at which x value does this gradient exist on our cubic function. So that is the whole idea with this. So step 1, find the gradient at d. Now d is this point on the cubic function where we know that the x value is equal to 0, okay, because it's a y-intercept. So let's find the gradient at this point. So we'll use the graph of f and we'll derive it. And once we derive that, we'll be able to find the gradient where x is equal to 0. And of course, that'll be the gradient at d and also the gradient at t. Okay, so we need our graph. Well, we already have the gradient of f. Okay, so this is the gradient of f. Let's just take this as it is and go ahead and find out what will the gradient be where x is equal to 0. So what is the gradient at x equals 0? When you substitute, you'll realize that you're looking for the y-intercept of the derivative of f, which is just 8. So we can simply tell them, okay, this will be 8. And now that we know that it is 8, it means that the gradient of the tangent, right, at d and t, that they're both equal to 8. Again, how does that help us? If we know the gradient of this tangent is 8, and that one is also 8, then we can find out on this cubic function, where does it have a gradient of 8? It will give us two x values, of course, because it has a gradient of 8 at 2 points at d and t. So let's find out where that gradient is equal to 8. Again, we'll be using this function. We're going to use f prime of x because this is the general gradient of our cubic function. And we're going to find out where is this gradient equal to 8. Okay, so from this equation, if you transpose 8, you see that it will cancel. So 8 is gone on both sides. We might as well take all of this over so that the x squared is positive. So that is 3x squared minus 10x is equal to 0. And now we have to factorize this binomial. So we have a common factor of x. So we're going to take out x as a common factor, and what is left in the first term, we will have 3x. And what is left in the second term? We have negative 10 is equal to 0. So x is equal to 0, or, and here we'll solve for x, you can say 3x is minus 10 is equal to 0, and then that's equal to 10, and then divide both hand sides by 3. So x is just equal to 10 over 3. So you see how we got a 0 and we got 10 over 3? That makes perfect sense because we know that the gradient was equal to 8 at 0 over here at D. And now we know the second place is at 10 over 3. The whole point is to find OG. If we know that this happens at 10 over 3, this x value of 10 over 3, we know that the x value of t and the x value of g are exactly the same. So OG is 10 over 3. So we can just conclude that and tell them the x value of t is the same as the x value of g, and that's 10 over 3. Therefore, OG is 10 over 3 units, and that is our answer. Okay, so that is it for this question, and moving on to the next question. Question 8.5 says, determine the value of m if y equals mx plus c. So that's a gradient they're referring to. If this graph intersects f perpendicularly at x equals 5. Okay, so this is a lot like this question. They're using the same idea. So we have the graph of f, which was a cubic function. And they're saying that we need to find m, the gradient of a line which is perpendicular to f at x equals 5. Remember that we had an x-intercept here, an x-intercept of 6. So this line is somewhere where x is equal to 5, right? So it's maybe somewhere here. But they're telling us that that line is perpendicular to the graph of f. So if we had a tangent at this point over here, right, on the graph of f, then that line would be perpendicular to that tangent. Okay, so it's really that same idea. All we're just doing is we need to find out exactly what the gradient of the cubic function is at x is equal to 5. And we find out what that gradient is. That's going to be the gradient of that blue line. That's going to be the gradient of the cubic function at x equals 5. And then we will just apply that it is perpendicular. This line is perpendicular to it. Okay, so we just need the gradient formula again. So let's take that, the gradient of the cubic function. Okay, so this is our function, the derivative of f, the gradient. So we want the gradient specifically at the value where x is equal to 5. So we'll substitute that in here. And that gradient is negative 17. So f prime of 5 is negative 17. So that's the gradient of the cubic function at that point where x equals 5. That gradient is negative 17. Now we know that the gradient of the cubic function at that point is perpendicular to the gradient of this line at that same point. So to find it, we're going to just say the gradient that we have, right, multiplied by the gradient we're looking for is equal to negative 1, because if lines are perpendicular, the product of their gradient is negative 1. So this is negative 17. You don't have to do this long method. You can say times m2 is equal to negative 1, and then solve for that gradient by dividing both hand sides by negative 17. So that would just mean, let's just call that m. The gradient of that line we are referring to is simply 1 over 17. And that is our answer. And that is it for question 8.